This is Paris, early June 1981, the 34th Salon International de l'Aéronautique et de l'Espace, known throughout the world as the Paris Air Show. Every 2 years, aviation leaders from around the world gather for technical seminars to fly their latest and best products and to buy and sell aircraft. This event brings aviation professionals from more than 200 countries to Paris. It is covered by more than 1,000 members of the International Press Corps. During each show, one single aircraft seems to evolve as the technical and emotional favorite of both the professionals and the more than 500,000 spectators who attend. Quite simply, 1981 was the year of the XV-15 Tiltrotor. These quotes typify the reaction to the XV-15.
The technical hit of the show, according to both aviation experts and pilots, was Bell Helicopter's XV-15.
For many, the Tiltrotor had more crowd-pulling power than the fighters. While no one stirs from lunch to watch fighters, a good many men and women in the business of aviation rise to get a clear view of the XV-15, and they applaud.
This tiltrotor aircraft is quiet. The concept has great potential for city-to-city flights from centrally located heliports.
The Bell XV-15 performed every day at Le Bourget a remarkable demonstration which left no doubt about the validity of the concept of a tiltrotor.
A star in flight demonstrations. I wish the Soviet Union had this technology in hand.
And if there was a lovable plane, it was the XV-15, the hit of the show.
Here is the flight demonstration as it was seen by spectators at the Paris Air Show. The quiet and seemingly effortless vertical takeoff to hover quickly established that this was a different type of aircraft. The aircraft's excellent handling qualities were readily apparent. As the XV-15 went from sideward flight to rearward flight, it demonstrated the maneuverability that is required to work in confined areas like a helicopter. This was the moment of greatest anticipation, conversion from hover to forward flight. To demonstrate the flexibility of transition, the XV-15 began its conversion sequence while backing up at 30 knots. And this was a view that couldn't be seen from the ground. The simple low pilot workload conversion. A single thumb switch is held in a depressed position for only 12 seconds. A conversion that could be interrupted at any time by merely lifting a thumb. The airspeed goes rapidly from 0 to 170 knots in less than 15 seconds. From the ground, the rapid acceleration was clearly visible. In cruise flight, control is just like a good turboprop airplane, with the wing providing smooth aerodynamic lift and the rotor providing steady forward thrust. The sensation was similar to any fixed-wing aircraft. Due to the high lift capability of the wing, the tiltrotor displayed maneuverability normally associated only with fixed-wing aircraft. Rapid changes in flight path were exhibited, maneuvers that are needed by low-flying military aircraft. And in contrast to conventional helicopters, the tiltrotor can fly at high altitudes, up to 30,000 feet. So it can fly smoothly above the weather and at altitudes where the most efficient fuel consumption is realized. With its small wing, the tiltrotor proved to be quite insensitive to turbulent gusts, so the ride was smooth. As the XV-15 made a high-speed pass over the crowd, there was a sudden hush, because even at 500 feet, the aircraft noise was virtually undetectable. Quite simply, if you weren't looking in the proper direction, you probably missed the flyby. This was in sharp contrast to the ear-shattering roar heard in most high-speed flight demonstrations. The efficiency of the tiltrotor in this cruise mode was impressive. Twice the speed and twice the range of conventional helicopters on the same amount of fuel. Transition back to the helicopter mode was as easy as the original transition. A brief 12 seconds as the aircraft slowed from 130 knots to 80 knots, and the reconversion was complete. This rapid transition from airplane to helicopter mode permits high approach angles which better utilize airspace and further reduce the landing noise footprint of this inherently quiet vehicle. A quick bow to the applause of the crowd. Once comfortably in a hover mode, the aircraft could be lowered to a soft precision landing. It demonstrated that it could land even in high crosswinds. The first military test pilot to fly the XV-15 probably said it best. The Tiltrotor is as easy or easier to fly in the hover mode as any helicopter he had ever flown. Industry observers at Paris were impressed by one other thing. The Bell Tiltrotor made all its scheduled demonstration flights with a consistent reliability. The spectators who came to see a Tiltrotor demonstration were never disappointed. Even with the runway blocked, the Tiltrotor, by lifting off from the taxiway, was able to fly. Perhaps most impressive of all, from a reliability point of view, only one spare part was needed during all the weeks in Europe, a UHF radio. Even more exciting than the advanced technology demonstrated by the XV-15 are the potential applications that exist within the military. Derivatives of the aircraft which flew at Paris have immediate applications for many critical missions. Take search and rescue, with a configuration that might look like this. A 20,000-pound gross weight, with space for 6 litters, and with twice the speed and range of current rescue helicopters. Hover has proven to be very stable with low downwash, which facilitates rescue. Or this might be a typical gunship mission profile. A takeoff from hover, followed by a 50 nautical mile high-speed flight. Then more than 2 hours of search time, plus 30 minutes of maneuvering combat, and a flight back to base with a 30-minute fuel reserve. With a crew of 2, such an aircraft could still carry almost 4,000 pounds of ordnance. In a forward air controller or reconnaissance mission, a crew of 2 would have endurance of almost 4.5 hours. The wide speed range from NOE flight to 300 knots increases battlefield survivability. There could also be more than 1,600 pounds of payload. This is an all-new Tiltrotor design, one that is larger for more mission applications. The Tiltrotor will change the whole concept of marine assault. Faster, more flexible, much more efficient. From ships lying offshore as much as 50 to 200 nautical miles, it would be possible to make a high-speed deployment of 24 troops plus a crew of 4. When coupled with high-speed air cushion vehicles, a whole new tactical approach becomes possible. Best of all, from the logistical point of view, Tiltrotors are self-deployable around the world. Thus, extremely rapid response time is possible for small operations, such as hostage rescue, or large operations, such as the Rapid Deployment Force. This reduces the number of Air Force transports needed to get a fighting force into action. The horizons of anti-submarine warfare can also be rolled back by Tiltrotors. They could operate from carrier decks, or even from non-aviation ships. They can be launched and recovered at any time without requiring ship maneuvers. The high speed of the Tiltrotor reduces the area of uncertainty and thus increases the probability of recontact. At the same time, when recontact is made, the ability to fly slow means better weapon drop accuracy. Also, the efficient hover and loiter capabilities are ideal for dipped or towed sensors. Additionally, since the Tiltrotor can operate off destroyers and fly at high altitudes, it is ideal for airborne early warning and over-the-horizon targeting. Such aircraft equipped with a 360-degree radar would be capable of long loiter times, and they can target for surface and subsurface launched missiles. And so it goes, mission after mission. Carrier on-board delivery, tactical transport, intra-theater transport from damaged airfields, or medical evacuation. The unique combination of fuel-efficient, fast flight, coupled with true VSTOL performance, offers combat commanders the ability to rethink entire tactical concepts. military doctrine itself can be improved dramatically. So for the military, the tiltrotor represents a quantum jump in capability. The advanced technology demonstrated by the XV-15 tiltrotor is exciting, but the practical applications of this concept to civil aviation are truly revolutionary. Take offshore oil support, currently being done by helicopters in the North Sea area. Presently, this is the effective range of helicopter operations. A tiltrotor in the VTOL mode could expand the envelope to this size. And with a short takeoff run, the tiltrotor radius would expand to 750 nautical miles. Such a design could carry 40 oil men and their equipment, plus a crew of 3. It would have a pressurized cabin, full de-icing, truly all the modern flight amenities. Here's a graph of costs per passenger mile. At a 300-mile range, the tiltrotor would be less than a third as expensive as current helicopters. And it could fly those extra miles that are beyond current or anticipated helicopter technology. For commuter use, the tiltrotor would provide the convenience of a helicopter with the comfort of a jet airliner, plus the economy of a turboprop commuter. For the first time, the elusive goal of rapid city center to city center transport will become a reality. Downtown New York City to downtown Boston, about 190 miles in 34 minutes, door to door. With comfort comparable to any corporate jet. Airline-style seating, stand-up headroom, a refreshment center, galley, and lavatories. The tiltrotor is an aircraft designed for quiet, comfortable, routine air service. This smaller version would be the ideal corporate aircraft. The flexibility of high-speed point-to-point transportation for better utilization of executives' time. This aircraft will carry 16 passengers at a cruise speed of 300 knots. It will have true engine-out performance on takeoff, and it will land and take off vertically and quietly. It's just the answer to the demands of modern corporate transportation, and perhaps best of all, it's cost-effective in 4 separate areas. First, the tiltrotor has twice the productivity of a helicopter, so it cuts costs dramatically. Second, the fact that it reduces point-to-point travel time saves the valuable man-hours of corporate users. Third, the low vibration means minimal maintenance on airframe and the dynamic components. And fourth, the cruise efficiency means fuel savings. There are many other specialized uses in the civil sector. Here's a good example: search and rescue. Quick launch from a fixed base with a high-speed dash to the rescue coordinates. A range of up to 400 miles, endurance up to 3.5 hours. Precise hover with low downwash, and a cabin large enough to permit adequate in-flight medical care. It's likely that the tiltrotor will become the optimum search and rescue air vehicle, just as it will impact many other civil aviation missions. And for good reason. Nothing but a tiltrotor can do the job as well. The VSTOL flight regime has been a challenge to the aviation community for many, many years. Dozens of companies all over the world have spent hundreds of millions of dollars over a period of 2 decades trying to develop an aircraft type that was fuel efficient in both hover and high-speed cruise flight. Because of new technologies, Bell's tiltrotor is now a practical VTOL aircraft. Engines are more powerful and lighter than they were in the days of Bell's original tiltrotor, the XV-3. There are also composite materials which provide more stiffness with less weight, and there is now fly-by-wire, a weight savings control system technology. Bell Helicopter has been able to integrate these technologies and couple them with detailed computer analyses of rotor dynamics at high speeds, proven in flight by the XV-15. And the benefits of efficient cruise is more important now than ever before. It shouldn't be too surprising that this tiltrotor is a Bell Helicopter product. Who should be better qualified to design and develop a VTOL with the characteristics of a helicopter? And who should be more capable to adapt the various disciplines that comprise helicopter technology than Bell? After all, Bell is the company that has built more helicopters than all the other manufacturers in the free world combined. Now, Paris 1981 has proved that Bell Helicopter Textron has the VTOL technology that works. The Tiltrotor. It's more than a new way to fly. It's a new way to think.